Hello again, ladies and gentlemen. We are finishing up the back of notes 1.2 continued, or part B or part 2. Basically, just to recap, we talked about the theorems that apply whenever we have two parallel lines and they're intersected by a transversal or diagonal line. So now we're going to work out some problems. In the last video we went over the guided notes and filled out those. So now here we're going to work on this back sheet, okay, and use this as an example. You can work on the practice problems that are going to be assigned later. All right, so we're given a problem that says, okay, given that the measure of angle 5 equals 109 degrees, find each measure. Tell which postulate or theorem you used. So we're going to go through this one by one. Now let's go ahead and mark our angles first. And that's actually what's going to be on your Google slides. I have boxes for each of the angles, so we need to go ahead and mark it. So we're told that angle 5 is 109. Okay? So write 109 in this box next to 5. All right, so now let's look at 7. Angle 7 is a vertical angle. So therefore, we're going to put 109. Okay, because remember, vertical angles or a bow tie are going to be congruent. All right. Now, when I look at angle 6 and angle 7, they share a line in common, so therefore their bases form a straight line. So remember, that's going to be a linear pair. So that means that we're going to say because a linear pair, the two angles equal 180. Come over here. We're going to say 180. You don't have to do this part. Minus 109. That gives you 71. So that means angle 6 is 71, okay? Angle 6, if you need to pause it, please pause it and fill out the form as you need to. Angle 6 and angle 8, they're also vertical angles or a bow tie. So that means this is also going to be 71, okay? Now we move on to angle 3. Angle 3, if you notice angle 3, angle 8 and angle 3 are consecutive interior. And remember, consecutive interior angles are not congruent. They're supplementary. So that means that we're going to take 180 and subtract 71 from it. We should get 109, okay? So that means the angle 3 is 109 degrees, okay? Angle 3 and angle 1 are also vertical, so we're going to write 109 for those two. Okay, I'm going to circle these so that way you know which angles, what to put in each boxes. All right. Okay, now angle 1 and angle 2, because they share a base line that forms a straight line, they're a linear pair. So again, we're going to say 180 minus 109, and that should give us 71 again. So we know that angle 2 is going to be 71 and angle 4 is going to be 71 because they are also vertical angles. 2 and 4 vertical angles to each other. All right. So now that you've filled out all the angles, it should be easy to fill out all the forms on the left. So let's start with question 1. Question 1 says the measure of angle 3 is what? So we come over here. We notice that angle 3, we already put it. So we're going to put 109. All right. Normally we would put the degree symbol. Equatio should be working. That's our math formula editor. So you should be able to insert it there. Make sure you watch the video on it. But if you cannot, I'll accept 109 just because I know finding that degree symbol is a little harder. All right. You could actually go to in Google Slides, you can actually go to insert special characters and insert degree symbol. So either way, you'll be able to put a degree symbol in there. All right, so this blank right here is the theorem that applies. So that is going to be alternate interior, because angle 3 and angle 5 on opposite sides, but they're both inside. Okay, so that's why angle 3 is going to be 109 because remember, alternate interior angles are congruent. All right. So now move on to angle 7. Angle 7, we come over here. We know it's also 109 degrees. Okay, and then we look at angle 5 in comparison. So angle 5 and angle 7, they're right across from each other, so they're vertical angles because they form a bow tie. So we're just going to write vertical here. Okay. Next, move on to angle 2. Angle 2 is, we said 71. And when we compare to angle 5, because they're on the same side of the transversal and they're both inside, they are consecutive interiors. So again, I'm going to write it. And if I go over, I apologize, but you should be able to write it in your box. So consecutive interior. All right, angle 4 is 71 degrees because we already wrote that already. All right, and when we compare it to angle 6, now we're not comparing to angle 5, now we're comparing to angle 6. Angle 4 and angle 6 are alternate exterior. Okay. And then lastly, we have angle 1, which is down here. We know it's 109 because we solved it already. And when we compare it to angle 5 again, they are, because they're on the same side, but one's inside, one's outside, remember that's going to be corresponding. Okay, so that's how you should fill out those. And the problems you'll have later on, practice problems, you'll do the same thing. So if you need to, feel free to take a screenshot of this and use it to help you fill out the practice problems. All right, so the next kind of problem you may see is it says name the angle pair and then find the value of x. All right, so we look at this, we have 2x minus 10 here and 80 degrees here. Now if we look at it, they're both inside our parallel lines. Remember, these two arrows here are triangles tell us that these are parallel lines. So because they're both inside of the parallel lines, we know that they're going to be interior, and one's on the left, one's on the right. So that means they are all alternate interior, and when they're alternate interior, remember they are congruent or equal to each other. So we're going to say 2x minus 10 equals 80. And then we just solve for x, because that's what it asks us to do. So we're going to add 10 to both sides and get 2x equals 90. Divide by 2 on both sides and get x equals 45. Okay? So that's what you should put. Try to show all your work here, guys. As I've seen several of you actually doing this. Make sure you're showing your work. We need to act like we're in school. We're in face-to-face school, so you do need to show your work here. That way, if you make a mistake, you know, I can point out the mistake, you know, to you personally and say, oh, here on problem number 6, instead of adding 10, you subtracted 10 from both sides or something of that nature. But when you just put an answer down, I don't know how you got that answer. And if you get it wrong, I can't tell you, oh, well, da-da-da-da. All right, so number 7, we move on to that one. So we look at this angle here and this angle here. You notice one is inside, one is outside, but they're on the same side. They're both on the left side. So that can only be corresponding angles, okay? All right, so remember, corresponding angles are also congruent. So we're going to say 3x plus 15 equals 12x minus 10. All right, so now you can take one of 2 approaches. Let's go ahead and take the 3x from both sides. Okay, we're going to subtract 3x from both sides and get 15 equals 9x minus 10. And then we're going to add 10 to both sides and get 25 equals 9x. And we're going to divide by 9 on both sides and get x equals 2.8. So guys, sometimes we will get decimals, so don't freak out if you get a decimal. But again, just know that all of them may not be like that question number 6, where it was just a whole number. There was no decimal, so we may get decimals here. All right, so move on to number 8. If you look at number 8, you see that they're both on the same side. However, they're both inside. So remember our rule when we say consecutive interior, we want to look for our C, okay? I forgot to point out on question number 6 to look for our Z, but again, I'll highlight that too for you. So that was our Z, remember? So that told us this was alternate interior. This tells us they were consecutive interior because we had the C. So we'll write consecutive interior, okay? So again, remember consecutive interior, now they're not congruent, they are supplementary. So that means that when we add the two angles together, they equal 180 degrees. So let's go ahead and combine our like terms. So negative 5 and 94 give us 13x minus 89 equals 180. Then we're going to add 100. We're going to add 89 to both sides because the inverse of negative 89 is positive 89. And get 13x equals. I'm sorry, positive. I apologize, Mr. Harper. Can make mistakes, and that's why I say for you guys to make sure you're writing your steps, because that way you can see when you make a mistake. So again, that was positive 89, so we're going to subtract 89 from both sides and get 13x equals 91. And then we're going to divide both sides by 13 and get x equals 7. All right, so that finishes up problems 6, 7, and 8. Now, numbers 9, 10, 11, we don't have to state the, I will mention it, but we don't have to actually state the theorem we're using. All right, so let's look at this part. All right, well, for angle y, variable y is pretty easy because if you look at it, we have 62 over here and y here. They're both outside, so that means they're alternate exterior angles. And remember, alternate exterior angles are congruent. So that means that y equals 62. So that was pretty easy. We didn't have to do any calculation there. It was just simply knowing that 62 and y are congruent because they're alternate exterior angles. All right, but however, 4x minus 2 and 62 are not alternate exterior angles. So they are, however, it might be beneficial to go ahead, and since we know that's 62, and we can basically say, you could go ahead and say that this is a linear pair, but I think I have an easier way to handle this. Let's take this linear pair here, this 62, and then this degree over here. So remember, a linear pair is we subtract 180, we subtract that number from 180 to get 118, okay? All right, so now that we know that's 118, all we're going to now do is, because now these are corresponding angles, because 118 degrees is outside and 4x minus 2 is inside, we know that these are corresponding angles. We just go ahead and set them equal to each other because remember, corresponding angles are congruent, okay? So now we solve for x, we add 2 to both sides, get 4x equals 120. Divide by 4 and get x equals 30. Now we would have found this out the same way if we had just said 62 and said that was a linear pair, but again, whichever way you want to see it is fine. I don't have space to work it out. If we were in class, I'd work it out and show you the other way, but for right now, this is probably the easier way to look at it. All right? So move on over here. All right? Now we look at 6x plus 30 and 12x minus 6. Now, both of them are outside, but they're on the same side. So we didn't have a consecutive exterior angle theorem. So what we can do is look at this side right here. Look at this side right here. If I look at 12x minus 6 in that side, I see that they're alternate exterior. So I can put 12x minus 6 here, okay? Because they're congruent. So now that we know that that's 12x minus 6 as well, this now forms a linear pair, and we can say 12x minus 6 plus 6x plus 30 equals 180. All right? So we can go ahead and combine our like terms. So here we got 12x and 6x gives us 18x, and then negative 6 and positive 30 give us positive 24. Okay, and then bring down to 180. We'll subtract 24 from both sides and get 18x equals 156. And then from there, we're going to divide both sides by 18 and get x equals 8.7. Okay, so that's our answer for number 10. On the last one, guys, so thank you for bearing with me. All right, so we have 5x minus 10, we have 3y, and we have 115 degrees. All right, so what would be the easiest thing to do is to find out that these two angles right here are a linear pair. So we're going to say 180 minus 115. Okay, so we know that's going to be 65. So this angle has to be 65 degrees. All right, so now that we know that's 65 degrees, all we're going to do is notice that this 65 degrees and this angle over here are alternate exterior angles. So we're going to say they're congruent. So we're going to say 5x minus 10 equals 65. We're going to add 10 to both sides and get 5x equals 75. Divide both sides by 5 and get x equals 15. Okay, so that takes care of our x. Our y is just as easy because now that we know the 65, this angle right here, I'm going to erase that other part so it doesn't seem so confusing. This angle right here and the 65 are corresponding angles. So we know that that's going to be 3y equals 65 because corresponding angles are congruent as well. We're going to divide both sides by 3 and get y equals 21.7. Okay? So please feel free to take a screenshot of this and use it on your worksheet that you're going to work, well, the problems you'll work on later, and as well as your warm-ups and everything else, because I will be basing that on these problems. So that's it for today. Thanks, and I will see you in the next one. Bye.